Here, for integration by parts, remember it is the integral of u dv equal to uv minus the integral of v du. So the first step in integration by part is determine what's u and then what's dv to use this whole term in here to find the integral. So to find u, I'm going to use this acronym, which is ILATE. If we have these functions, which is inverse function, log function, algebraic function, trig function, and exponential function, I'm going to first choose the inverse function to be u. And then if we don't have this inverse function, I'm going to choose log function to be u. And then if we don't have these two functions, I'm going to choose algebraic function, and so on. And the rest is just going to be dv after we choose u. Now let's jump and solve some examples. So the first step in here is try to use u substitution and see if it does work or not. And if it does not, let's use integration by parts. So here we have this integral, the integral of x e to the x dx. I'm going to use u substitution. So I'm going to set u equal to x, and then therefore du equal to dx. Now, the integral on the top going to be equal to the integral of x, which is u, and then e to the u, and then dx is just du. Notice, this integral is the same as the given one. It's exactly the same. Here we have in term of u, and here we have it in term of x. So u substitution here does not work. So now let's look into integration by parts. Remember, integration by part, it is u dv equal to uv and then minus the integral of v du. The first step is determine what's u and what's dv. So to choose u, here we have two terms. We have x and e to the x, and we want to choose which one is u. So I'm going to use this acronym ILATE to determine what to choose for u. So what comes first in these numbers, I'm going to choose it. Here we can see that exponent is the last one, number 5, and algebraic expression, which is x to the n, is number 3. Therefore, I'm going to choose x, which is its algebraic expression, to be u. And then dv is the rest, which is e to the x dx. Notice in here, I want also to find the term v and du. So I'm going to find these from u and dv. So du here going to be equal to dx, and then v going to be the integral of dv. This is just a definition. So that's going to be equal to the integral of e to the x dx. This integral going to be equal to the e to the x. Now what I'm going to do is I'm going to plug all of these into the integration by parts. So this is going to be equal to u, which is x, then v, which is e to the x, and then minus the integral of v, which is e to the x, and du here is just dx. Now in the next step, I'm going to solve for this integral. So we'll have x, e to the x, minus e to the x, and then plus c. Notice here we have these common terms, so I'm going to factor that. Going to be e to the x, then x minus 1 plus c. And that is the antiderivative. Here we have the integral of natural log of x dx. Notice we didn't know what's the natural log of x. And even we can see clearly that we cannot use u substitution in here. So if we switch u to be x, then du is equal to dx, and this integral gonna be the integral of the natural log of u and then du. This is exactly the same one, but with a different variable u. So this does not work. Now let's try to solve this by integration by parts. Remember, integration by part gonna be the integral of u dv equal to uv then minus v du. First step is to choose u and choose dv. How to choose u? I'm gonna use acronym ILATE to choose u. Here we only have the natural log of x. Therefore, I'm gonna choose it for u. U is natural log of x, and then the rest is just dv, which is dx. Now we want again to find the term of du and v. So du here gonna be equal to 1 over x, which is the derivative of the natural log of x, and then dx by the chain rule. And then v is the integral of dv, which is the integral of dx, which is gonna be equal to x. Now let's plug all of these into the integration by parts. So this is going to be equal to u, which is natural log of x, and then v, which is x, and then minus the integral of v, which is again x, and du here, as notice it's 1 over x dx. So notice here x gonna be divided by x, which is equal to 1. So we're gonna have natural log of x, then x minus the integral of dx. Now in the next step, I'm gonna find this integral. So this is gonna be equal to the natural log of x of x, and then plus c. Here we have x as a common term, so I'm gonna factor this out. So we'll have x, the natural log of x minus 1, and then plus c. And that is our antiderivative. Now let's try to solve this integral, which is the integral of x squared cosine of x cubed dx. First step is always check if u substitutions applies in here. Notice in here that u substitution will apply in here, because when I'm take the derivative of x the cube, it's gonna be 3x squared, and we have this term x squared also. So again, u going to be equal to x cubed, and then du going to be equal to 3x squared dx. Now we only have x squared dx, so I'm gonna move 3 to the other side. And then this integral gonna be equal to, I'm gonna just arrange first, so it's gonna be of cosine x cubed and then x squared dx. Notice in here we have cosine, and x3 is gonna be equal to u, and then this term x squared dx going to be equal to 1/3 of du. Now I'm gonna pull the constant out of the integral, and we have the integral of cosine of u du, and we already know what's the integral of cosine. So that's gonna be 1/3 and then sine of u plus c. Now we're gonna back substitute the function of u, which is x cubed. So that's gonna be equal to 1/3 of sine of x cubed plus c, and that is our antiderivative. Now we have this integral x cosine of x dx. Let's use u substitution here. Notice in here, I don't think u substitution will work. I will choose u to be equal to x, and if y take the derivative of that, it's gonna be equal to 1, not x. So let's check that. So u equal to x, and then du is gonna be equal to dx. And this integral gonna be equal to u, and then cosine of u, and then dx is just du. This is exactly the same one we are giving, but with a different variable, so u substitution does not work in here. So now let's use integration by parts. Remember, the integration by part, it's the integral of u dv equal to uv, and then minus the integral of v du. So the first step is to choose u and to choose dv. To do that, I'm going to choose the ILATE acronym. Here we have two expressions. We have x and cosine of x. So we have algebraic expression and then we have a trig expression. Here from ILATE, we can see that the algebraic expression comes before the trig expression. Therefore, I'm going to assign u equal to x. And then the rest gonna be equal to dv, which is cosine of x dx. Now again, I want to find v and du. These I'm gonna find them from u and dv. So du going to be equal to dx, and then v going to be equal to the integral of dv. That going to be the integral of dv, which is cosine of x dx, and the integral of cosine going to be equal to sine of x. Now we are ready to put these into the integration by parts. So this is going to be equal to u, which is x, and then v, which is sine of x, then minus the integral of v, which is sine of x again, and du here is just dx. Now the next step, I'm going to solve for this integral. So this is going to be x sine of x, and then minus the integral of sine of x is actually minus cosine of x, and then plus c. Remember, to know the integral of sine of x, just take the derivative of cosine. The derivative of cosine is minus, so add a minus sign to be a positive sine of x. So that's gonna be equal to x sine of x, and then plus cosine of x, then plus c. And that is our antiderivative. Now we have this integral, which is the integral of x squared e to the x. The first step is to decide if u substitution applies in here. So I'm gonna set u equal to x, and then therefore du is dx. So this integral gonna be equal to u squared and then e to the u, then du, which is exactly the same as the given one but with a different variable. So u substitution does not apply in here. So now let's try to solve this by integration by parts. Remember, integration by part is the integral of u dv equal to uv minus the integral of v du. The first step is to determine what's u and what's dv. So I'm going to use the ILATE acronym to know what's the function that I'm going to assign it to u. Notice in here we have two expressions. We have algebraic expression, which is x squared, and then we have exponential expression, which is e to the x. The one that comes first in the ILATE, I'm going to choose it to be u. Notice here, the exponential is number 5, and the algebraic is number 3. Therefore, I'm going to assign x squared to be u. And then dv gonna be the rest, which is e to the x dx. Therefore, du here going to be equal to 2x dx, and v going to be the integral of dv, which is the integral of e to the x dx, which equal to e to the x. Now we are ready to use the integration by part. This is going to be equal to u, which is x squared, and then v, which is e to the x, and then minus the integral of v, which is e to the x, and then du here, it is 2x dx. So we're gonna have x squared and then e to the x, and then minus, I'm gonna pull that out of the integral, so we're gonna have 2, and then the integral of x e to the x dx. Notice in here, we also need to apply the integration by part again. So let's apply it for this. Again, we already know that u gonna be equal to x. Let's call it u1 equal to x, and then dv1 gonna be equal to e the x dx. du1 going to be equal to dx, and then v1 going to be the integral of dv1. That gonna be the integral of e the x dx, gonna be equal to e the x. Now we are ready to use integration by part in here. So we'll have x and then the x dx. This is going to be equal to uv minus integral of v du. This is by integration by part. Note in here, just to differentiate these variables from these variables, I'm gonna call this u1, v1, and then v1 and du1. So that's gonna be equal to u1, which is x, and v1, which is e the x, minus the integral of e the x, and du1 again is dx. So we'll have x, e the x, and then minus e the x. That's the integral. That is the integral of this term in here. So we'll have x squared, e the x, and then minus 2 of x, e the x, and then minus e the x, and then plus c. And that should be our antiderivative in here. Notice in here, also we can factor these terms in here, but I will leave it as it is.